Good morning, everyone. Let's answer the questions of moving charges and magnetism. Let's see the multiple choice questions related to the moving charges and magnetism. Let's see the first question. Two charged particles traverse identical helical paths in a completely opposite sense in a uniform magnetic field. B. B naught cap cap. This is a multiple choice question and this question has four options. Option 1, they have equal z components of momentum. They must have equal charges. They necessarily present a particle antiparticle pair. The charge to mass ratio satisfy E by m1 plus E by m2 equal to 0. Here is the thinking process. So the correct option of this question will be D. Let's see the explanation. Explanation is here. For given pitch D correspond to charge particle, we have Q by M equal to 2 pi V cos theta by QV equal to constant. Since charged particles traverse identical helical path in a completely opposite sense in a uniform magnetic field B, LHS for two particles should be same and of opposite sign therefore. E by m1 plus E by m2 equal to 0. Let's see the next question. The Biot-Savart law indicates that the moving electrons velocity v produce a magnetic field B such that, let's see, we have four options for this question. B is perpendicular of, B is parallel to B, it obeys inverse cube law, it is along the line joining the electron and point of observation. Here is thinking process. Here use of Biot-Savart law play vital role. In Biot-Savart law, magnetic field B IDL into R. Here IDL due to flow of electron is in opposite direction of V by direction of cross product of two vectors. So the correct option of this question is A. Let's see question number 3. This is question number 3. A current carrying circular loop of radius r is placed in the xy plane with center at the origin. Half of the loop with x greater than 0 is now bent so that it now lies in yz plane. This is a MCQ question, and this question has also four options. Option A: the magnitude of magnetic moment now diminishes. The magnetic moment does not change. The magnitude of B at z-axis 0, 0, z, z greater than r increases. The magnitude of B at origin, z 0, 0, z, z far greater than r is unchanged. So the correct option of this question is A. Let's see the question number 4. Here is the question number 4. An electron is projected with uniform velocity along the axis of a current carrying long solenoid. Which of the following is true? This is also a MCQ question. The electron will be accelerated along the axis. The electron path will be a circular about the axis. The electron will experience a force at 45 degree to the axis and hence execute helical path. The electron will continue to move with uniform velocity along the axis of the solenoid. So the correct option of this question will be D. Let's see the question number 5. Here is the question number 5. In a cyclotron, a charged particle undergoes oscillation all the time. A speeds of between the ditch because of the magnetic field. A speeds of a D slow down with a D and a speed of between Ds. So the correct option of this question will be A, to change particle. The charged particle undergoes oscillation at a speed of between the D's because of the oscillating electric field, and second, a speed remains the same inside the D's because of the magnetic field out direction undergoes change continuously. So this is the answer of the question number 5. Let's see the question number 6. A circular current loop of magnetic moment M is in an arbitrary orientation in an external magnetic field B. The work done to rotate the loop by 30 degrees about the axis perpendicular to its plane. This is a multiple choice question, and the answer of this question is MB. Let's see the explanation. A rotation of the loop by 30 degrees about an axis perpendicular to its plane make no change in the change, but we are also the rotation of the loop by 30 degrees about an axis perpendicular to its plane imply that the axis of the loop will continuous to incline with the same angle with the direction of the magnetic field. Let's see the question number 7. The gyromagnetic ratio of an electron in an H atom according to Bohr's model is independent of which orbit it is in. Negative, positive increases with the quantum number. So the correct option of the question number 7 will be A. Let's see the question number 8. Consider a wire carrying a steady current I placed in a uniform magnetic field B perpendicular to its length. Consider the charge inside the wire. It is known that magnetic force do not work. This implies that motion of charge inside the conductor is unaffected by B. Charge of since they do not absorb energy, some charge inside the wire move to the surface as a result of B. This is the correct option. If the wire moves under the influence of B, no work is done by other force. If the wire moves under the influence of B, no work is done by the magnetic force on the ion assumed fixed within the wire. This is also a correct option or correct statement. So the correct statement of the question number 8 is available in A and D. So the correct option of this question will be B and D. Let's see the question number 9. Two identical current carrying coaxial loops carry current I in an opposite sense. A simple Amperian loop passes through both of them, once calling the loop HC. Here is the first option. Integral of closed surface B into dl equal to m into mu naught into y. B, the value of the closed surface B into dl equal to minus for the 2 mu naught I perpendicular to C. Third option or option 3, there may be a point on C where B and dl perpendicular to the behavior. Let's see the question number 10. Here is the question number 10. A cubical region of a space is filled with some uniform electromagnetic field. An electron enters the cube across one of its faces with the velocity v, and a person enters via opposite face with velocity v. At this instant, the electric charge on both the particle cause identical acceleration. The magnetic force on both the particles casual equal accelerations. Both particles gain or lose energy at the same rate. The motion of the center of mass Cm is determined above by the below. So the correct answer is BCD. In the next class, I will discuss some more questions and answers of this chapter. Till then, thanks to all of you. Thank you very much.